Hello everyone, I am Hayu from Malaysia Global Training Center. Now we are going to discuss on the topic of digital microwave principles. Upon completion of this course, you should be able to describe the concept and characteristics of the digital microwave communication, describe the theory and function of every parts in the digital microwave system, list the networking application for digital microwave systems, list the fadings in microwave propagation, and the common technologies of anti-fading. There are 4 contents in this slide. The first one is the digital microwave communication overview. There are many methods of transmission. As you can see here, this is coaxial cable, fiber, microwave, and satellite. These are the advantages and disadvantages of the fiber and microwave transmission. As you can see here, there are a lot of advantages and disadvantages when comparing the microwave and optical fiber. First one, easy to cross the space, few LAN needed, and can avoid the private LAN. For optical fiber, the optical fiber construction is large LAN used. For the microwave, low investment, short period, and easy to maintain. For the fiber, it's a high investment, long construction period. Microwave is usually used for anti-natural disasters strongly because of the easy to be restored fast. For the fiber, it's outside cable maintenance, natural disaster influence. However, for the microwave, we need to apply the frequency license. For the fiber, there's no frequency license required. But the microwave, the performance will be affected by the weather and landform. However, for optical fiber, performance is stable, less influence from the outside. And microwave can only support low transmission capacity, whereas the optical fiber can support a high transmission capacity. Microwave, the definition of a kind of electromagnetic wave. The radio frequency range is from 300 MHz to 300 GHz. It can be regarded as a plane wave. The electric field and magnetic field exist at vertical of transmission direction of plane wave. So it is called as a transverse electric and magnetic field wave, or TEM. The communication that uses microwave as carrier is a microwave communication. The microwave communication with digital baseband signal is digital microwave communication. There is an intermediate frequency between digital baseband signal and radio frequency signal. This is showing a chart for the developing of microwave communication. Note that the capacity less than 10 mega is considered as low capacity. From 10 to 100 mega is a medium capacity, and more than 100 mega is a large capacity. The common frequency bands used are listed here, 7 giga to 38 giga. This is a traditional band. As you can see here, there are some examples where the common frequency bands are used. The central frequency, TR spacing, and channel spacing are defined in every frequency band. So, for example, in this scenario, we have frequency scope whereby we have the central frequency F0 to divide between the low frequency band and the high frequency band. So here we have channel spacing, and this channel spacing is actually dividing the few channels available on each low frequency band. So we have F1, F2 up to Fn. So we have on the high frequency band, you have F1 prime up to Fn prime. And here the TR spacing means that from transmit to receive. So F1 to F1 prime, TR spacing. So this is an example of the frequency band and the channel. So here is given the frequency scope is 7425 up to 7725 megahertz. So the central frequency is 7575 mega, F0. So the TR spacing used is 154 megahertz, and the channel spacing between the channels is 28 megahertz. And the high side and the low side is Fn and Fn prime. So here the value that we took is, for example, is 7442 for the F1, and the F1 prime should be 7596. So this is within the frequency scope of 7425 up to 7725 megahertz. The modulation modes for microwave. The microwave carrier is a digital modulated by the baseband signal. As you can see in this diagram, this is the digital baseband signal, which usually represented by the service signal. So here, the service signal will actually be modulated into the channel bandwidth, and it will actually change into intermediate frequency signal. But this IF signal will need to be modulated again, changed to radio frequency signal before it's transmitted into microwave transmission. The frequency carrier signal can be described as given in this formula. It is represented by the three main components, which is the amplitude, frequency, and phase. There are four common modes, but the most commonly used are PSK and QAM. This structure showing the radio frame complementary overhead, RFCOH. In this structure, the RFCOH is attached with the STM1 and the payload. Here you can see there are informations included inside the RFCOH. RFCOH and STM1 data are blocked by multi-frame. There are 6 rows in a multi-frame, 3564 bits per rows. A multi-frame consists of 2 subframes, subframe 1 and 2, and 1776 bits for one row in a subframe. The other 12 bits are used as frame synchronization. Thank you for watching.